Hello, my name is Tabby, and today I will be talking about displaying matrix data on the Ti84. By this, I don't mean like matrix data in the way that people usually use it, like for actual maths, because the Ti84 is a calculator. The main thing that I'm using it for today is just displaying the Pi integer numbers on the screen, and in a way that allows you to display it even if the matrix is bigger than the screen size via scrolling with the horizontal and vertical offsets that we'll talk about later. In this video, I'll also tell you how to do this with a string, since those are considerably faster to draw to put on the screen, and that might be more suitable for your needs if you're working with more static data than things that need to be changed relatively frequently. So I will tell you what I will be doing first. We want to find the n sizes, and by that I mean we need to find the dimensions of the matrix first. So the only way that I've really found to do this is by putting the dimension command with the matrix that we're doing, which is the A matrix for the example of this video. And then the answer of that is put the answer to this. Let's say this matrix is 5 by 4. The answer would be like for dim A. If I put that into my Ti84, it would have put out like, what was it? Did I say 5 by 4? A string of 5, not a string, a list of 5 and 4. Now, for some reason, we can't interact with that from the command, so we can't say dimension A, the first element of it. We can't do that. It doesn't put out any workable answer. So we have to do is a workaround, which is the answer variable. The answer variable has this information stored, whatever calculation had been done. So for example, this dimension A stores the list, and from here we can get the first element, which will be the height, and we'll store this into A, where the height of the matrix. And then the second element will be stored into B, the horizontal end, not the end, but the horizontal, the horizontal end of the matrix. So, horizontal end of the matrix. And then we have the vertical end of the matrix. Now, once we have this, we want to fit it to the size, since if we're, for example, if we're doing a for loop, like looping for all of these, but like n is equal to 1 to a, if we have something that is bigger than the screen, let's say 10 high, this would immediately give us an out of bounds error, since the Ti84 screen is only 8 high and 16 long. It can only display with like the output command, which outputs a string character to the screen starting at a certain coordinate from either 1 to 8, let's say, and 1 to 16. Then we can use our character, which we'll just say C in this case. An interesting thing about the Ti84 is that it starts at 1 for its lists and matrices and, well, screen coordinates, because we start at 1 here. And it also starts with the coordinates of y then x instead of x then y, which most people is usually used to. That is something you have to keep in mind. I also just mentioned passingly that we do not have to fill out the brackets. It's in fact quite very slower on like processing if you do that, so I recommend anytime that you can leave out brackets, the ending brackets, at least if it's at the end. That is off topic. The next thing we have to do is fit the dimensions to the screen if they are larger, so fit dimensions. So like for example, if A, the vertical end, is more than 8, the end of the screen vertically, we put 8 into A. So we just refit it. And if B is more than 16, the horizontal width of the screen, then we put 16 into B. Very easy like this. Now we can actually output our data, which we do a for loop. Let's use a dummy variable n, and let's use a dummy variable m. N will be the vertical dummy variable for the the rows, we'll start that from 1, the first position, to A, the ending of like the vertical thing that we've set. So it's either going to be less than 8 or at 8. And same thing with M, 1 the start, and then B the end horizontally. Then we can just put ends here. Now you can do conditional logic if you want in this. I'll just output the variable, the answer, how it is. So we'll output n m and then a. Okay, then we'll do this from n m. Now how we have it right here is it only outputs it from the first, well, from 1 to the end. And if the thing of the matrix is bigger than that, then we wouldn't be able to access all of the matrix's data. So from here, we're going to introduce 2 more variables. These are v, the vertical offset, and w, the horizontal offset. And what these do is, for when the A and or B dimensions is bigger than the screen, we can simply append this to the coordinates, so n plus the offset, and m plus offset, and it offsets it by how much it is. I will have to warn you, the offsets assume that the A dimensions and B dimensions, or the A dimensions and the B dimensions, are bigger than the screen. If you want, you can... What I'm doing is, I'm assuming that you know this and you trust the user to know this. If you wanted, you could, in here, also state, like, then, and we could just set this hard set to 0 store into V, then, and 0 is stored into W. Guys, I'm an idiot. I'm making this while I'm editing the video. Don't do this, like, at all. It doesn't help you at all. I was misconstrued. You would not want this. I'm just telling you. Keep it like this. Even with my own logic, it goes against what I was saying, because I said if it is smaller than the screen, set it to 0, and I put it in the code that does it explicitly when it is bigger than the screen. If you do want to do this, literally just say, like, if A is less than 8, it's just like the opposite. 0 store into V. If B is less than 16, 0 stored into W. It's as easy as that. So whenever you see the old piece of code, just don't use it. And I'm so, like, I'm putting it here just so if you're following this as a tutorial on your Ti84 that you don't make this mistake, just leave it as this. And if you want to include it, just put this right on top. That's what you should be doing. I also made the same mistake when doing the string section, so just do the same thing for the string section as I said here, okay? Thank you. And that's really it for the displaying matrices. Now, as I promised, I'll do the same thing, but with strings. So, yeah, strings. I'll also put my thing a bit larger so I can see. Much like doing matrices, it's the same, except much, much faster, because, spoiler, when we get to the loop section, we'll only have to do the vertical rows, which is about calculating 118 less loops, like, worst case, which is way more preferable. So, if you have static data, I implore you to use strings. If you have data, like map data for a maze or something, if you're, like, making a game on the Ti84, which a lot of people do, I would recommend that. But either way, let me introduce the one variable that you will also need for this. D, the dimensions of the strings, columns. So basically, how many columns are on the string. This allows us to, basically, since, strings are obviously one-dimensional, we'll have to know where the end is. This just gives us how long it is. So same thing how we did the matrices. We'll find the dimensions. And for here we have D, which is how many columns that's stored into B, because that is horizontal end. Same thing here. The length of the string, we'll use string 1 in this case as an example variable, divided by D, which is because D is how many things it is, and the length is going to be how many is in total. From that we can get the height, which will be stored into A, and that will be the vertical end. And much like how we did matrices, we can fit these dimensions. Oh my god, dimensions. So if, again, I can literally copy and paste this. There, easy. Now for displaying the string. So first we have a for loop. Again, dummy variable, we'll do n here. We'll do it from, I'll have to explain now. So let's just say we have the loop set already. So just loop. We're going to be outputting this from the basically n plus 1, because I'll tell you why in a second. It's because we're gonna start n at 0, because the way we're gonna do this is by just adding our answer onto 1 to not get an out of bounds error. I'll explain that in a second, okay? So we'll do for n is equal to 0, and we're gonna do this until a minus 1. We have to minus it by 1 because we're setting everything back by 1 here. Now, we can do our output like we said before, n plus 1, because, again, we've set everything back. When we're displaying, we have to plus it by 1. And then we do this at 1 because it's always going to be at the first element, not the first element, the first position horizontally. And then here, we'll use a substring command. So sub, how the substring command works is there is a string, there is the position of the string starting from 1, so 1 to string length. I guess I should do it like this, 1 to string length. And then we have how long do you want the substring to be, so like 3 elements long. So here we want to obviously get the size, not the size, the starting position, which we will calculate in a second. And then we will want to get the size to be basically the, if it is smaller than, you know, how long it is, and if it's bigger, the width of the screen, which we can simply do as b since we've calculated that before. So the real difficulty here is getting the starting position. I'll calculate this in its own line, the initial position. So right now we just want the vertical position, like position that we've calculated, and we want to plus it by the horizontal position, which is obviously going to be the horizontal offset, which is w. Now I will say here, we'll have 1 here. Why? Because, as I said before, w and v can both equal 0, because it has no offset is nothing. There's no offset. At least the way that I've done it. And to mitigate that, we'd have to plus it by 1, since if we have a 0v, 0w, then it would start at 0, which, as I stated before, the substring command can only subdivide the string starting from 1. You can't start from 0. So that's why we're plussing 1 here. And also and this also explains why we have to do the math of the n starting from 1 here. Because we'll do, to calculate the vertical position, what we want to do here is, right now we'll just do n plus v. This is the vertical position currently plus the offset. The reason why we're calculating it here is because if we didn't, we'd have to use brackets. And as I said, brackets slow things down a lot. So instead, we're just using n plus v, and we're going to use the answer variable that it comes from, because the answer will store. This is basically stored into the answer. So yeah, it's going to be 1 plus. Now to calculate, obviously, the vertical position, we have to do d times the vertical position we're on. So yeah, we're going to do plus z times answer, because that is we are getting the current row that we want to access. And yeah, that's basically how you do it. If I do find out that I am wrong at all, I will make a correction in the description or the comments. If you have any questions about things that I didn't explain so well, please ask them. I will respond to them the best that I can. And I believe that's most of what I want to tell you, what I want to show you today. If you have any questions, please ask them. I'm more than happy to answer. And if you have any personal corrections or any personal tips, I would also like them. Again, I should have stated this before, I'm not an expert in Ti-BASIC. I'm a novice at most. I just do things, little programs are fun. So, especially for this section, if you know a better way to do this, I would greatly appreciate it. It feels wrong that I have to put this in 2 lines. That's like at least 2 extra tokens that are unnecessary. Or at least 1 extra token of this ants. So yeah, have a good day. I hope you got what you were looking for. Bye.